Assalamualaikum and a good day to chairman, panelists and participants. We are from UiTM Perlis. We'll be presenting our topic titled as Satellite Derivation of Depth and Total Suspended Sediment Assessment from Estuaries Erosion Monitoring within Narrow Straits using Sentinel-2A satellite images. Estuary is a connection area between land and sea, where these areas serve as crucial nurseries and habitats for diverse organisms. This area also experiences important natural processes such as sediment transport that leads to the sediment catchment within river, estuary, ocean, supporting existence of other ecosystems. Anthropogenic activities such as tourism activity has been increasing each year, and this activity has started to take place in nature. This activity, however, has been disrupting the balance and the process occurring in the estuary, causing the environmental distress and erosion. This exposure and natural stresses eventually will enhance the impact on other neighboring marine ecosystems that rely on sediments for sustaining their ecosystem or habitat. Various studies have supported that these changes monitoring will take time and effort, and remote sensing techniques is one of the solution keys to tackle this issue. Over the years, remote sensing has been widely used for tracking and continuously monitoring because of the numerous advantages compared to traditional field sampling method. However, an integration of analysis utilizing the depth and TSS from these newer satellite images of Sentinel-2A expected to improve the existing sedimentation monitoring system have not yet been well addressed. This study aims to explore the use of Sentinel-2A satellite image for water depth and TSS derivation to monitor the sediment flow, erosion and status of estuarine area around Langkawi Island. This leads to the objective of this study, which is to determine the applicability of the SDB and SDTSS estimation by Sentinel-2A satellite images with respect to in situ data and to analyze their correlation for sediment flow monitoring capabilities of estuarine area around Langkawi. Study area of this study are located at Bagan-Nyor, Langkawi, which are a narrow estuarine channel, one of the major routes to Pulau Tuba and Pulau Dayang Bunting, Langkawi. Recently, the island has proven to be one of Malaysia's greatest vacation destinations. Satellite images are acquired from Sentinel-2A for 2018 and also 2020 of the study area, with 10% of cloud cover from Sentinel Data Hub. The image was pre-processed for radiometric and atmospheric correction. For SDB assessment, the depth was calibrated for tide correction, and after the correlation analysis between bend ratio and depth was carried out, to proceed the estimation of depth, the correlation of determination R² must be at least 0.4, which is a moderate correlation. Finally, the Stumpf ratio transform SRT was applied. For SDTSS, in situ data for TSS are acquired using gravimetric method at 6 sample stations along Bagan-Nyor Strait. To obtain the estimation of TSS, the Normalized Suspended Material Index NSMI technique are applied utilizing the RGB band. Both of the results are evaluated with performance of satellite-derived estimation. Data analysis includes in situ data, and satellite-derived data were analyzed with Pearson correlation and coefficient determination in linear regression. For SDB, bathymetric map at Bagan-Nyor Strait for 2018 show a lower depth prediction compared to 2020 depth with average reading of 4.09 and 4.65 meter respectively. The biggest contrast in depth is at Station 1, even though it was expected as the shallowest due to a cloud shadow covering which disturbed the depth estimation of the area. Unexpectedly, Station 6 point, which among the deepest point, showed the least affected depth changes, where it recorded the lowest range of negative 0.1 meter. This was due to constant in and out of flows of sediments at the estuary opening. Significant changes was expected to be obvious at the Station 6 point. For SDTSS, in situ TSS and remote sensing data have a strong relationship, about 80% in R², and lower NMAE and RMSE with 0.031 and 0.001 respectively. Overall, SDTSS concentration within the study area have slight changes of TSS distribution pattern within the strait, and obvious changes occurred just beyond the strait area between 2018 and 2020, where the biggest TSS change found was at Station 5, where TSS concentration has reduced from 2018 to 2020, and the second highest difference is at Station 3, even though the station was in the arc area. The difference in Station 3 is due to human activities such as jetties maintenance, resorts, shales in the area. In addition, there are sediment loss from the riverbanks was visually observed at both sides of straits between 2018 and 2020, with clear difference in the band 8, the NIR wavelength, indicating the riverbanks area were affected the most when compared to the middle area of the strait. Overall, the changes of TSS in the strait was reduced with average of 0.053 mg per liter, and the depth within the strait was increased at average 0.56 meter between those 2 years. For coefficient determination, R square was about 82% in 2018 and about 75% in 2020, which indicates positive signs of integrating both depth and TSS parameter in analysis. The estimation from satellite images and analysis between both parameters are related significantly with p-value of less than 0.05 and very small standard error in 2018 and 2020. Aside from natural events, human intervention across the strait were the main contributors to the landscape changes, TSS variation, and depth level. Near to the station in 2018, while acquiring in situ data, we observed jetty maintenance at Station 4, tourism activities such as chalet and restaurant at Station 2, and floating hotel in progress at Station 1. However, in 2020, all stations show decline in TSS, where this event may reflect to the less of human activities during the COVID-19 pandemic. From this observation, this study has found that depth differences and TSS concentration does have relationship with anthropogenic activities. As a conclusion, the use of remote sensing has been proven to be reliable and effective, aside from traditional continuous data collection and monitoring. Therefore, it will improve the quality of environmental studies in the region. The TSS and depth also proven to have 75 to 82% significant relationship, verified as good satellite remote sensing integration. The SRT and NSMI technique also shown to be reliable for determining depth and TSS, with great correlation between remote sensing data and in situ data. This method can be further used in other TSS and depth assessment in other areas, and the data hopefully could improve the monitoring of estuarine area and assist the stakeholders for conservation and sustainable development planning in the future. Thank you.